Awogbade. I'm an ML researcher at ML Collective. My work majorly focuses on speech processing with the context around efficiency, but that's not the part here. So, yeah, the question here is how can you contribute to ML research from where you are? Now, where you are is subject to, it's very subjective. We all are at different places. We all have different backgrounds. Some of us have a CS background. Some of us don't have a CS background. I know. Well, so this is going to be the flow. The flow will be, we'll talk about the meat, the why, the how. Then if there's time, there will be side gist, but I doubt, because everybody that's been speaking here since I've not had enough time. So we'll just go with what is most important. Bear with me. So yeah, the meat. Can you? So the most common myths about ML research is people assume that, oh, you have a PhD or you need a PhD. Next slide. That you need a PhD to contribute to ML research. There's also the myth about how, oh, what counts as good contribution in ML research is a groundbreaking idea. For instance, maybe solving the limitations of an autoregressive model. Autoregressive models are your transformers, what powers your LLMs and all. Or maybe solving reasoning problem. In case you don't know, I hope you know your large language models, they don't reason. What they do, they infer from memorization and all. But all of those are like the big ideas or the big problems people are trying to solve now. There's also the myth that, oh yeah, you have to work at a university or at a research lab. Like that, because sometimes, not most times, but sometimes you need a lot of compute to do ML research, and most times you likely get them at the university or lab, or you have to be like an Agba scientist, like maybe a top researcher to actually do ML research and stuff like that. Now, why this myth hold people back is because our understanding of research is still very limited. Like what we tend to define ML research as. We see ML research as, oh, the core thing where you use a lot of maths, you do a lot of maths, but not in all instances. But research basically is anything that involves knowledge contribution. It can be as simple as evaluating the impact of an idea or the impact of a model. It cuts across the whole technical stuff that involves a lot of code writing. You could be doing ML research and you write no code. You could be a legal practitioner and you are doing ML research. Like, you can do ML research from any background. So research basically is knowledge contribution, things that advance the state of AI. Because the goal for building all of these models is so they can think like us, they can achieve human intelligence, then possibly super intelligence. But that's, so yeah. So if you get this was like a small survey. If you get this joke here, it means like, oh, you follow a lot of ML people. By ML, I mean the research side of ML, because yes, there's ML engineering and all. Because this is Jeffrey Hilton and co. winning the Nobel Prize in Physics, and it caused a bit of rancor in terms of what was the relationship between physics and computer science and all. If you don't get it, it means that you don't have a lot of people that do ML research in your space. Now, it means you should start following people that do ML research. But next slide, please. Yes, so, like, for me, this is like one of like if not the most important part, or the most important reason why, because this, in the long run, will define what you call impact when you do research and all. So, by unique perspective, what I basically mean is what makes you unique, what makes you you, your background, all of the things that have come to define your person. So let me give you an instance. So research is not like it's not close to large language modeling, but language modeling is the most relatable thing here. So let me use language modeling as an example. So yes, we're trying to teach computers to talk, to understand our language, to talk, to interact with us, to achieve human level of communication. But yes, the thing is, the goal is beyond them being able to generate text and you be able to like communicate with them in text. It's also, the goal is to get them to the point where they understand language, even to the point of culture. Because you know that your language is connected to culture. I hope everybody does know that. Because the culture informs the language. I don't know all of them, but I know they are deeply connected and they have deep roots and all. Now, that's what makes you unique. For instance, I have a Yoruba background. There's very limited knowledge I know about other tribes outside of Yoruba and the uniqueness of their culture. Even in my being a Yoruba background, I only know just the part that I come from, and that's the Jebu part, where we like parties and all those stuff. I don't know if it affects our language, but yeah, maybe. I'll ask my mom later. But yes, that's like the unique perspective and all. So it's not limited to language modeling really, because it cuts across many other areas. I just have to use that as an example. So yeah, there's personal growth. If you do research, when you start doing research, you are forced to learn a lot. You have to learn so much in a short amount of time. Let me give you an instance. Sometime last week, I was trying to replicate a work on. So, like I said, I do speech processing. So I was trying to replicate a work on text-to-speech and all. And their approach had to do with, they use flow matching. Yeah, it's just some simple maths and all. So basically, it led me to conditional normalizing flows, led me to ordinary differential equations, blah, 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 simple stuff here and there. My point is, I wouldn't have, all of what I've had to learn in that short amount. Why? Is maths hard? It's okay, simple stuff, honestly. I still don't get the hang of it, but it's simple. And all of those stuff. But really, it's not limited to maths. There's still many other things. My point there is that because research, you have to read a lot and you have to know a lot. So it forces you to read, it forces you to widen your scope, things that you would not necessarily use. You could even use it to build work experience. Because, for instance, you have to do some evaluations of some models. Then you have to learn this tool, learn that tool, learn this tool, learn that tool. While you don't have a job, that's like you have acquired some wonderful level of work experience or no. But jumping to networking opportunities, you get to meet people. Top guys, most of all the guys that I know today, they are from maybe conversations via emails or even in person at conferences and the likes. And some of them have helped my life. Yeah, recently, that's about 3 weeks ago, I had a call around 12 a.m. I know the guy was calling me from Ontario in Canada. And he was like, hey, Busayo, are you, sorry for waking you up, are you available for this gig? I know I'm blah, blah, blah. I'm supposed to do some evaluations for them. And in my head, I was wondering, why would I not be available? It's money. But that's by the way. All of this came about because of research and all, jumping on walks, doing experiments here and there, blah, blah, blah. Sorry that I said blah, blah. I promised my brothers at home that I will not be saying blah, blah, blah. I have to sit them down together to prepare for this talk so that I don't pass 10 minutes, but I failed. So, yeah, the fun part was not fun about waking up 3:15 a.m., thinking about your life, wondering if I wasted your BSc. Yeah, that was what happened that last week when I was learning conditional normalizing flows. Because I didn't know what I did in school for a CS graduate. But moving to the next slide, please. So yes, the how. Yes, you're going to read a lot of research papers. Get that in. You have to be a sucker for knowledge. You have to want to learn. But now, how do you do that? Next slide, please. Yes, yeah, there are many ways to go about contributing to research. There's open data problems. That's data gathering. You could be even evaluating machine-generated data, and or it could be you creating data from scratch. Imagine you're looking to expand the knowledge of, let's say, your GPT-4 in quote. You want it to be able to speak and write Yoruba, but not just the popular Yoruba, maybe Ijebu Yoruba kind of thing. That kind of an instance, we will need people that can speak it and people that can write it to create that kind of data set. So you see your uniqueness. At that point in time, we can't use machine to generate that. I don't know if you make... So there are so many other things like that. There's even the open source projects that you can use to contribute to data. For instance, I don't know if you know, for those of us that do LLM fine-tuning and code, your QLoRa, your LoRa, it all came about from an open source project started by Team Data and all. And now it's one of the things that allows us use... Okay, I've not been talking to this site since. It's one of the things that allows us use LLMs in productions and the like. Forgive me, the slide is there and all. So yeah, you can also create benchmarks. You can evaluate models in different domains and different contexts. So to submit at a top conference, you have to do a lot of evaluations. You have to do an exhaustive evaluation. But nonetheless, there's so little that the authors can cover. Case in point, I have that experience, for instance. So one way you could also contribute is by taking all of these released models or ideas or technique, then put them to test under different things. The same thing applies to empirical studies. I failed my brothers. The same thing applies to empirical studies. Empirical studies basically stress testing maybe an idea or a model. Let's just keep using model in this context, where you try to see, okay, how well does it work under this context? How well does it, so things like adversarial testing, where you introduce noise into your data just to see, okay, is this model smart enough? So for instance, your ChatGPT is to some level very robust. You could ask it a question and you make spelling, wrong spellings and all, you will still get a sense of it. That's some level of robustness. You could stress many other things. It does not have to be ChatGPT. There are speech models and like, hey, you contribute domain expertise and all of that. By domain expertise, I mean your background. If you're a linguist, like this now, if you're a linguist, you're an hotcake. You are very sought after in the whole ML space, particularly language modeling and all. Now, the how of how. See, all of those things I said earlier, they sound very easy to do, but they're hard when you start. So the way you actually get to do that is by joining open science communities. For example, ML Collective, Masakani, the Deep Learning in Daba, Koye for AI, Uta AI, Roya CV. I, for myself, I've benefited a lot from all of these conferences. MLC sponsors my trip everywhere I go. And like I'm an ambassador for MLC, by the way. I lead the Nigerian chapter. I co-lead the Nigerian chapter with my friends, Stephen Kolaole, Oyosori, Abraham. They're top guys no, they're not top guys like me. So yeah, summary of it all. If you want to contribute to ML research, you need, first of all, let me just, sorry, please. 2 sentences, 3, I like. 2 sentences. You can contribute to ML research from where you are, from your background. You don't have to have that maths expertise and all of the things that have stopped you so far. You can, that's one. Then secondly, how? You have to join an open science community. The same way Data First Africa and the other data communities you have joined have helped you so far. That's how these communities also help you. You can sponsor your trips to conferences. You travel all over the world. Okay, I've been to 2 countries. Thank you. You're welcome. Feel free to come talk.